Assalamualaikum, we are from Group 15 and we've been given this task to design a shaft. So first off, a shaft is a machine element that transfers power from one part to another. So in our case, we want to design a drive shaft. A drive shaft is used to transfer torque from the engine to the wheels. Since it is an important part of a modern car, a maximum safety is required. So therefore, in our project, we will look to design a drive shaft that has an ideal safety factor.
Hi, my name is Ruben. I'm going to explain about types of shaft. There are two types of shaft, which is transmission shaft and machine shaft. Transmission shaft is used to transmit power to machine part source. Counter shaft, line shaft, overhead shaft are the example of transmission shaft. The next is machine shaft. This kind of shaft is working as machine part. In other way, the shaft also called as machine part, that's why it's called as machine shaft. The next, I'm going to explain about shaft material. The material we selected for our drive shaft project is aluminum alloy. It commonly used for heavy duty structures. Aluminum alloy is also corrosion resistant.
Assalamualaikum and hi, my name is Ashraf. I am the one who made the design of this shaft. I used Inventor to design the shaft. After we had the value of calculation, we ran simulation to get the stress analysis. By analyzing the stress analysis, we get the result and know either our shaft is good or not. Furthermore, by using Inventor also, we can get the detailed drawing. Inventor is the best application to use as an engineer because it helps us a lot in designing and in decision making.
Hi, my name is Pierre and here I am presenting the calculation part of this project. First of all, since the system is in static equilibrium, the sum of the forces in any direction is equal to 0. So, after adding in the force of the wind into the calculation, we know that the Rx is equal to negative 2051.83 Newton, and for the Ry is equal to 590.63 Newton. And as for the moment of the reaction, we got 6155.49 Newton meter. Apart from the structural analysis, the safety factor has to be determined in order to justify whether the shaft is safe to use or not. So, after calculated the shear stress of the shaft, we managed to calculate the safety factor of the shaft by using the formula of the N is equal to U strength of the material divided by 2 times the maximum shear stress. For the section of diameter 100 mm, we got a safety factor of 5.67, and for the 130 mm, we got a safety factor of 12.42, and for the 170 mm, we got 28.14 for the safety factor. Thank you.
For discussion, the structure or component can fail, collapse, shatter or break if the device of structure is subject to loading over the strength of the material. Is it clear from the result obtained from both the measurement and the FEA that the material is safe to use as a substance for the construction of this shaft? Aluminum alloy can be said to be suitable material used to build the drive shaft as it is rigid material that can endure torsional loading or fatigue loading without failure experiences. As for conclusion, we can conclude that aluminum alloy is the most suitable for the shaft because from the calculation and the finite element analysis or FEA, the safety of the shaft that designed by aluminum alloy is safe to use as its safety is higher than 1. However, to ensure that the aluminum alloy is safe to mass produce, take into consideration a series of calculation, analysis and simulation to justify aluminum alloy as the most suitable material and safe to be used.